Now. So welcome everyone to our today's webinar at Mavuno Technologies. We are introducing our product release version 1.0 today. That means after our successful launch of our MVP, the very first product version in January, and a lot of experience we have collected with this MVP and a lot of data we could collect, we have now completed our very first fully fledged product, and it's an honor to us to introduce that to you today and the technology behind. So today I'm pleased to welcome Jakob, our co-founder Jakob, to the stage, who is in charge of our data science at Mavuno, who will present what we are actually, how all the technology works behind, and Stefano, who will demo the app and will explain how all this all the app and technology works in our cloud infrastructure. This milestone today is very important to us because it marks also the start, or the start of our operations, mainly in our market in Tanzania. So as of now, our farmers, we have 200 farmers now in Tanzania, are utilizing the results of our app to improve their harvest yields. And we are in a critical moment now because we can now leverage this product with further investment from Europe to grow our farmers to 1,000 members, therefore massively help a lot of farmers already this year. And the upcoming 6 months will be very important for us at Mavuno, because then we can really prove that our business model, that our product works, and that we can help smallholder farmers in Africa, in our first target market in Mtwara region in Tanzania, a lot. So that was a short introduction of what to expect today. We also have time for questions and answers. And then I would say I give the word to Jakob, please.
Thanks, Johannes, and also thanks everyone else for joining in today. I'm quickly gonna share my screen because there's something prepared here. So today we are all gathering to celebrate the release of the first version of the Mavuno app. And some of you might remember that early this year we have already released the MVP of our product, which came with the most basic features, which let us validate the applicability of our app for Tanzanian cashew farmers. And today we are very proud to announce the first full version of our app, which comes with a farm location management feature, which lets operators monitor multiple farms at once using one smartphone, and also with a disease risk assessment tool that helps Tanzanian cashew farmers fight diseases more effectively. And in order to get there, we have been working quite hard in the last several months, and we have, within a very short amount of time, we have reached quite a lot of goals, both on the data science and on the engineering side. And let me quickly first start with the achievements on the data science side, and then tell you a bit more about it. So firstly, we have developed a crop type classification model using the Sentinel-2 data, which can identify cashew trees from other vegetation types. We have developed a disease risk model that can identify the cashew trees that are more likely to be diseased using the Sentinel-2 satellite data. And we have also developed various methods to improve the Sentinel-2 data quality using noise filtering and outlier detection. And at this point, I would especially like to thank our interns, Ali and Joling, to help me develop the crop type classification model and the noise filtering method, and also Nashiva to help me with the analysis to develop the disease risk model. So let me tell you a bit more on how this all works by explaining the full data pipeline from the raw Sentinel-2 data to the disease maps that are shown on the user's smartphone. All this actually happens every 4 to 5 days for every region of our farmers, because every 4 to 5 days we have a new image taken by the Sentinel-2 satellite. And actually, you can, here's also a quick overview of what the resources on the AWS cloud look like that we use to read and write the data. So firstly, we are using an AWS 3 bucket to read the original Sentinel-2 data, which is stored from the last, since 2017, so more than 4 years from all around the world, which allows us to do historical analysis from all of our farmers, basically. And all the process data we store in these 2 buckets, all the data that we process. So these 2 buckets are part of our own ecosystem. And also all the geospatial data and further metadata we also save on AWS on DynamoDB, which is an AWS database. And so yeah, the Sentinel-2 data originally is actually saved in a so-called military grid reference system, which is organized. Let me actually show you this on a command line real quick, what this looks like. So first of all, here we have the regarding S3 bucket on AWS. Then here is this one is latitude, longitude and latitude. Then the ID of the grid of the tile inside the grid cell and the date of the product. And this is what actually one of these products looks like here on the command line. And these products, so one of these products is actually quite large. So if we look at the image of one of these products, they are around 100 kilometers across. So what you see here on the left is actually the raw Sentinel-2 image from Mtwara. So this here's the Mtwara region. Here is actually, I think here's the border of Tanzania. This might already be, yeah, this might be the border already. And this small red dot here is one of the, on the top left is one of the regions that we monitor, which you can also see here on the right hand side. So the size of the regions of the farmers is much smaller than this very large Sentinel-2 image. And that's why we actually, in the very first step, we process these very large Sentinel-2 images into much smaller files, which we then store on AWS on these resources that I just showed you. The Sentinel-2 data actually also comes with various further raster data, such as the scene classification label raster, which or short SCL raster, which contains all the scenery information of each pixel. So, for instance, vegetated pixels or cloudy pixels or cloud shadow pixels, and this helps us to do a basic quality assessment of all of these pixels on the map, and check and sort out bad pixels like cloudy pixels, or completely skip data products if they're completely covered by clouds. And we also developed an algorithm that enhances this SCL raster to further improve this quality assessment. And after that, we also apply a further processing steps to further improve the Sentinel-2 data quality, such as outlier detection using span-specific thresholds, and then also 2 machine learning-based filters, the G filter, which is used to reduce outliers that still occur after that, and the double logistic fitting, which we apply to NDVI, and which can also be used to identify the seasonal pattern of different kind of crops, which is also very interesting later on for crop type classification, or also for disease risk assessment. So in this next step, a crop type mapping step, we actually identify cache trees on the image, on the map, first by identifying vegetated pixels, differentiates vegetative pixels from other pixels using the NDVI threshold, and then by applying a light gradient boosting classifier, which is applied by which was trained by 400 carefully selected ground data labels that we have collected a few months ago, and that are both cashew trees and different and other vegetation types. So yeah, and after identifying these cashew tree pixels on the map, the next step is applying the disease risk model to these pixels, which happens with a polynomial regression, which detects cashew trees which have a seasonal pattern that varies from the normal seasonal pattern of these cashew trees, and therefore can be classified in different levels of disease risk. And that all will then be visualized as heat map images and stored again on the cloud on S3. And from there, it will be loaded to the user's smartphone and displayed on the mapping interface. Yeah, and that's basically it from my side for now. Stefano will show you a bit more on how this actually all looks like on the front end. And I'm going to give the word to him now. Thank you.
Thanks a lot. Thanks a lot. We talked about visualizing heat maps on generated by satellite imagery and so on. So let's actually have a look at how it looks on a real phone. Let me share my screen. And by the way, thanks mainly to Hassan for having contributed to this app. Is actually the main contributor at the moment. And here we go. You should be able to see the my screen. And this is how a farm location in the Mtwara region looks like. So we can actually move around. We are focused on one of the managed location. Yeah, in fact, it's not that far from the Afli Center. And let's say we want to have a look on how it's going on with regards to disease infestation. I can click here on this Dava button, all the app in Swahili. I mean, we support English. At the moment, we just haven't implemented the possibility to switch. So if you would have your phone set to English, you would see English. But for the sake of the presentation, I set up to have Swahili as my default language. So let's actually have a look. It looks like we download the heat map. You can see here we have a marker indicating the center of the whole farm location within the region. And you might notice here on the right, and top right, those spots, those red spots. And actually, this legend is suggesting that the more red the shade of those spots, the more intervention is needed to actually fix the issue with disease. That means that maybe a bit more pesticides, our operators should apply a bit more pesticides in this specific area on those specific trees. That was just at a glance to just build a bit the connection between what Jakob's team and what the data modeling team is doing and how it end up in the end in a smartphone. But I would like to give you a bit more background about our whole ecosystem that we like to call the Mavuno ecosystem. And that's basically here. We try to summarize this in one page. So all the things that Jakob previously explained, those are basically can be put inside a box. This box is basically, say, taking over the responsibility of downloading the images, processing them, and then generate those images. And then afterwards, we can actually notify whether there have been errors or not. But that's only one side of the coin, I would say. Because we provide much more than that, as you could see on the top. if I manage to zoom, of course. In fact, what we provide is actually first of all an API, so that we are able to communicate from the smartphone, from the client, from our operator smartphone to whatever is the result of the data processing, and then also to manage as I said before, some unexpected events and receive notification about those. So I am quite proud to say that our backend infrastructure leverages the latest technologies, and in particular the latest serverless offering by AWS. And these allow us basically to be able to develop fast, let's say at a faster pace, and have basically no issue about scalability. Being able to deploy fast as well. This was actually one of our concerns, and actually I was working before at the latest change that we are doing in order to be able to pre-fill database table, one of those tables that Jakob showed you. And since I like to scare my coworkers Johannes and Jakob, this part hasn't been rehearsed, and I'm gonna actually deploy the API live, just to give you an idea on how easy it is for us, or at least how much effort we put in being able to actually deploy as fast as possible our API or our infrastructure. Deploying our infrastructure for us is like launching a program on a computer. So we can replicate this process as many times we want for as many environments as we want. Here I'm deploying in dev, but I could do the same for our production environment and so on. And we actually do the same for our production environment and so on. So that's really, really extremely important for us to be able to deploy and scale fast. I mean, with this architecture, we can maintain our costs as a startup as low as possible, being fast on the market, not spending money for resources that we do not need yet. But then we could, if it's needed, could scale to millions of users without doing basically anything. Then let's quickly go back to the app. The stack is deploying. I actually wanna show you this first while I prepare the app. Let's maybe go back to the app while this process is going, and we come back to this in order to show that I'm not cheating. Because in engineering we don't actually handle with manage deployment. It actually is done. I can show it to you. Let's go to AWS. I will refresh. Boom! Our API is here. Our API is here, and we can call and interact with it. And let's actually interact with it from within the app, because among the latest features that we added, we added the possibility to handle multiple farm locations. So as both Johannes and Jakob said, we launched our MVP in January, and at the time we decided to focus on managing only one location per time. But of course, our operators needed more. That's why we implemented the possibility to deal with multiple locations at the same time. So if I go here on this left menu, I can actually navigate to Sehemunza Mashamba. I hope I pronounced this correctly. That basically allows me to go to the farm location manager. And here I can see my existing location. I already have 2 at the moment, and I can decide to remove them. And this will trigger removal also on the infrastructure. So basically doing the processing the other way around to delete a region and all delete local farm location and all the resources associated with that. And here I can also decide to add a new farm location. Here I can add a new farm location, but since I'm sitting in Europe, first I just have to tell my phone, I mean to trick my phone basically with another app. It's an app that allows you to teleport you basically everywhere. And I will now put myself in here in the Metwara region. Oh, there's a bit of green. I will teleport here. So now, according to my phone, I just traveled speed of light to Tanzania. So I can go back to the app. At this screen, I basically can stream my GPS position, so the position of my device for exactly 7 seconds. Why we want? I mean, it's not that we have fun making the user wait, but it's the more you wait, the more accurate is the GPS precision, the coordinates precision, and more reliable are also for then the data processing. So everything has worked out. I have here a success confirmation screen. I can actually click to go back to the map screen, and now we can see that I have three regions that from which I can basically switch the data processing, the creation of a new location. Sorry, I said region, but I meant location, farm location. The processing of each farm location requires a bit of time because, as you might think or imagine, I mean, we're dealing with big images coming from a satellite, so the computation associated with it is quite heavy. That's why we have to allow a couple of minutes, up to 5-7 minutes, to depending on the specific location, to be able to actually see then the result of the generated heat map. And that's basically it from my side. We have a lot more to come, but for that I will give back the word to Jakob so that he can give you an overview on our product roadmap. Thanks a lot.
Thank you, Stefano. So I'm gonna give you a quick overview of I'm gonna share the screen again. I'm going to give you a quick overview of what are the upcoming features that we have planned. So firstly, we want to develop a harvest yield forecasting model that we train with the data that we collect from our farmers, the harvest yield data and the geospatial data. Then, which will be interesting as well for the farmers associations we work with, and then of course one important feature which will enable that as well is the polygon feature, which allows farmers to enter or operators enter the coordinates of their farms and to extract the total amount of predicted harvest yield for this one particular farm. And then of course we also want to implement a weather widget, because weather data is actually quite important as well for pesticide management. And lastly, we also want to develop further models for modeling further parameters like crop nutrition, for instance, for more precise fertilizer application. And as Johannes mentioned earlier, we also are looking into further crop types, but all this mainly looks exactly the same. So it's all gonna be first the crop type classification and then the parameter modeling using the ground data that we collect on the ground. So yeah, that's basically it from my side. I'm gonna give the word back to Johannes. Thank you very much for listening.
Thank you very much, Jakob. Thank you very much, Stefano, for guiding us through our technology and our app. I think we have a very good impression now. Yeah, what is behind? There's a lot behind that you need to get some information on a smartphone, but it's important to see the entire chain that is needed to actually provide this value in the end. Yeah, that was basically it. Our presentation of the webinar and what to come next, what we're going to do now. And yeah, we wanted to ask, is there a question to some of the components, some of the parts we have just seen? Or a comment? Probably for most of you, like also for me, I'm also not a technician. The major part of that is quite unknown and quite stranger information, but it's still interesting to understand and see how the different pieces can fit together, and yeah, how we can learn from a picture that in the end that a satellite makes, how we can learn about crop and then apply.
So yeah, Johan is here, is Zaman here. So Jacob, thanks for nice presentation. I have a quick, you can say, comment. So this crop classification model, we did not see that, I mean, the disease is very important. So even if when you were talking about the disease on pixel basis, like how is the accuracy? Did you make the metrics, out of, did you make any assessment, how is the accuracy looks like out of 1,000?
No, the crop classification.
The disease identification, the disease one.
So we are kind of like in the beginning phases of the validation, because it's still collecting data, but it's now kind of around 70%. Okay. But we hope to improve it because we are still in the middle of our data collection, which is ongoing, because now we still have this ongoing growing season, and we hope like in the end of the spring season we also can improve our model.
Right, definitely, then that's fine. Yeah. That's
and the goal would be to reach over 90%.
Definitely, definitely. The better.
Maybe, yeah. So maybe also for the rest of the audience. So, what Zaman just said is, there's a crop classification. So we need to identify what kind of crop type we're dealing with, and then once we have identified this crop type, for example, cashew, then we need to identify whether it's diseased or not, right? And for both, we have an accuracy. So for the first, the crop classification, we already have an accuracy over 90%. So with over 90%, 91, I think, right, Jakob? Percent accuracy, we can determine whether it's a cashew nut tree or not. And then for the disease identification, we are at 70% now, but also the goal is, and there we need more data now in the running growth season to also push that above 90%.
And Jacob, do you have any like the plan in terms of serving the API? Like Stefano was saying nicely. So it is taking 7 minutes to process the whole area on the fly. Do you have any plan to reduce the time, by optimizing the backend?
Yes, actually, my plan is to implement a tile server.
I wanted to say that.
Yeah,
tile server.
Yeah. So basically, the idea would be to serve heat maps the same way Google Maps serves their heat map. So because at the moment also the images are quite heavy, because instead we wanna have something like a smooth navigation through the map and getting heat maps on different regions. So not really connecting, also a bit detaching the concept of having a farm and the area itself, like having an agnostic system that, like Google Maps, but for disease heat maps.
Yeah, so we do want to also implement our own long-term storage using a tile server for the satellite data, which will make also analysis and the modeling much more efficient than it is now with the original data source.
And Jacob, just the last one. I don't want to hold audience longer, so maybe we'll talk later. Just regarding, is there like a batch? Are you doing the batch processing, or are you doing the near real time one? So maybe we can think of the batch one. So you do like a weekly computation, and you just put it on a cache, just serve it the moment they want it. So you're saving a lot of time over the night, and so the whole your area of interest, you can think of on a batch processing.
Yes, exactly. Yeah. So as I said, actually, this whole processing pipeline is executed every time a new satellite image is taken, every 5 days or so. So yeah, this happens all at once, basically, for all of the regions at once. Yeah.
Okay, great. Thank you very much for your good questions, Saman. Saman actually is one of our 3 advisors to community, to Mavuno, to a startup. And this, as you can see, he is an expert in our technology, so he's challenging us there from time to time. That's very good, and supporting us, of course. Great. Are there further questions? If not, then yeah, I would actually say let's close the webinar. I will stop the recording, and yeah, thank you very much, everyone, for attending today.
Thank you, Johannes. Thank you, everybody. Thank you, Jacob. Bye bye.
Thanks.
Thank you.
Thank you.